麻州理工学院磁铁实验室已经做了一些新东西，他们利用磁力从水中创造能源。分裂铀原子时，其部分质量变成能量，很多的能量。这是核分裂，把原子挤在一起也能制造能量。两个氢原子可以融合成一个氦原子以及能量，这就是核融合。麻州理工学院正利用磁铁创造核融合能量。
If you were to weigh the helium atom that you made and compare it to the weight of the two hydrogen atoms that went into the reaction, you'd find that the helium weighed just a little bit less. And that small difference in mass is converted to a huge amount of energy by the famous equation E equals mc squared. E is energy, m is the change in mass from two hydrogens to one helium, and c is a number which represents the speed of light, which is 186,000 miles per second. C squared is the speed of light multiplied by itself. It's an unimaginably huge number. So an extremely tiny difference in mass releases a tremendous amount of energy. And that's what fusion is.
也是太阳不断燃烧的原理。但如果你抓到一小块太阳，可以把它放在哪里？答案是磁力，磁力瓶。史蒂夫·费法尔斯是麻州理工学院等离子体融合反应炉 tokamak 的主任工程师，他是反应炉的负责人。
We send the power for a medium-sized city through these 5-foot-thick concrete walls and on into the magnets of the tokamak, where we use them to produce a very powerful magnetic field. Inside the tokamak, we're going to heat a gas to 50 million degrees. Now, the center of the sun's only about 15 million degrees, and there's no material on the planet Earth that will withstand a temperature of even 1 million degrees. So we use all this power to make a magnetic field and create a magnetic bottle that holds the plasma away from the walls of the machine.
麻州理工学院每天用15000加仑液化氮，把电磁铁冷却到零下350度。冷却后，就可以透过磁铁把巨大能量脉冲传进反应炉。
The magnetic force is so great that it would lift a stack of cars as tall as Mount Everest, and it takes 100 bolts like this to keep the machine from flying apart.
机器的甜甜圈形状反应室内，气体被加热到原子失去电子，而气体成为等离子体。因为反应炉内部太热，无法观察，费法尔斯只能用模型显示如何用磁场感应产生核融合。
Now, if I take this horseshoe magnet and put it next to the plasma, you can see that the magnetic field from this magnet is having a fairly strong effect on the plasma. It can move it around. Now, we don't use horseshoe magnets in our research. We use electromagnets like this. So when we turn that on now, you can see the plasma has clearly been squeezed away from the walls of the tube. Because it's not touching the tube anymore, the plasma's hotter. It's not being cooled off as much by touching the tube, and that's what makes it brighter. So this is the very same principle that we use in our machine, only where this plasma is a few thousand degrees. In our machine, we're shooting for temperatures of 50 million degrees.
反应炉目前需要的能量超过核融合产生的能量，但是反应炉温度达到5000万度时，会跟目标更接近一步，产生电力照明全世界。此电力代替化石燃料，是廉价的电力。
It means that we will have a means to extract energy from seawater without causing pollution in the form of radioactive fuel elements that have to be disposed of. We will produce nothing but pure energy and light. That's the dream.